Previous videos we talk about all this. So this video will talk about measurement and classification of pressure. Perhaps maybe a few things about here. Um so to start, P gauge is equals to absolute minus the atmospheric. Okay. The gauge itself is what display on the gauge of your display over here. Okay. And then atmospheric itself is the atmospheric air of the because in Earth itself, as you know, there will be atmospheric pressure. So it's 101.325 kPa or 1 bar. Okay, and then P absolute itself is the P gauge plus atmospheric. So P absolute, as in other words, you can say is like for example, it's similar to weight. If you want to weigh the amount of mass of a liquid, okay, so if you were to pour a liquid inside a beaker, and then you have to when you put it on the weighing scale, it display maybe 5 kg. Okay, however, because you want to just measure only the amount of fluid inside, okay, so you minus away the beaker maybe 1 kg, so it will be like 4 kg. So this is the same analogy to our pressure. Okay, this is the empty beaker. Okay, which is like stagnant. We don't want because it's the situation wants you to have, in order to weigh, you have to put it inside something to weigh. Same thing with pressure itself is already present in the atmosphere. So yeah, I think you get what I mean. So from this graph, one keynote is absolute and atmospheric. They are different. So what does this mean? Okay, if the gauge itself is larger than 0, which is we call it the um blowing. Okay, because the gauge itself is larger than um gauge is larger than 0, so your plus atmospheric is higher than atmospheric pressure. Let's say atmospheric pressure, as I said, is 1 bar. Maybe because of this gauge itself, you add it up, it becomes maybe 1.1 bar or 1.2 bar. So definitely you're talking about blowing. Okay, the amount of pressure that is expanding, I would say. I mean, not expanding, but rather I think you know. So for if it's lesser than 0, okay, if the pressure is lesser than 0, lesser than atmospheric pressure, it will actually create a suction. Okay, create a suction that sucks everything in, because the atmospheric pressure, because your absolute pressure, okay, your absolute pressure is your absolute pressure is already lower than your atmospheric pressure. Okay, because due to the fact that the gauge pressure is negative. Okay, so this is negative. So atmospheric minus P gauge, you will get P absolute. So this is why when you measure at the absolute pressure is in some values that is yeah, I think you get what I mean. So therefore this is what it explains. If it's the keynote you just need to remember is absolute is larger than atmospheric. If the absolute is larger than atmospheric, you need to you have to know it's blowing. Otherwise it's suction. Okay. So for suction wise, it's the same as when you're in flight. Okay, in flight normally, if you're because your cabin itself is pressurized, so it's much larger than the atmospheric outside. So when you open it when the door when the aircraft's door is being opened, the suction is so called atmospheric itself. Okay, how do I say it? I think you get what I mean. So when you pressurize, you're lowering the pressure in the inside the okay, don't want to complicate things. Okay, anyway, so atmospheric is when larger the absolute is suction, and then absolute larger than atmospheric is blowing. That's all. Okay, I'm not gonna talk much, and then just let you know P gauge is the whatever thing that display over here, or the analogy that I've gave you over here. So yeah. And then now, so we have cleared away the classification of pressure and the measurement. Measurement and classification is just classification is you classify this type of pressure. A measurement is when you know do a calculation. And the techniques itself for pressure measurement is there's a few, there's three. Um, so you have to, so the first one is piezometer. Okay, you can only measure liquid. In this case is this one. Can only measure liquid, but however you cannot measure the gas pressure. So therefore the derived unit, therefore YouTube thermometer is actually used, which is this one. So let me explain how this actually works. It's very simple, I think. I think only lah. So S is equals to PA equals to P1. So the pressure in of the water itself, we call it P1. Okay. So fluid pressure inside the container is PA, as you can see, is the fluid pressure. Is equals to if you remember specific gravity is rho GH. Okay, is the amount of depth. Yeah, plus the pressure ATM. Okay, so this, as you can see, is the amount of pressure that is upon the fluid at this point. Okay, so PA is actually pressure at this point. Okay, with a depth of H. Okay, make sure again. So PA itself is the point A at the depth of H. So the pressure at this depth is atmospheric pressure plus the depth, whatever thing that contains in the fluid itself. Okay, so so PG is equals to PA minus P atmospheric. PA itself is the absolute pressure. So the gauge itself, as you can see, is the only whatever whatever in the fluid. Okay, so it's the same thing as the energy as this one. So the gauge itself is whatever thing that we are measuring about the fluid. So in other words, the atmospheric pressure is like the weight of the beaker type of thing. I think you get what I mean. So yeah. So this is a very simple utilization of two formulas that we have learned. The first one is the one that we learned earlier, which is where we which is this one. Okay, also the pressure head type of equation. And the second one is we utilize this pressure. I mean this equation. So we use two in this case. So if the pressure in the container is larger than, so the limitation is that if the container of the pressure inside the container is larger than the pressure atmospheric, because you're adding out, because it's a very simple tool. So you can only use this for this. So piezometer can only be used in this scenario. However, if the container pressure in the container is lesser than atmospheric, air will be sucked into the system. Okay, so to speak that you cannot have any pressure that is lower than atmospheric, because you'll create a suction. Okay, because um it's like the pressure outside, okay, the pressure outside and the inside is different. So imagine you have lesser than atmospheric, so definitely a lot of things will want to go in, right? Because you're having lesser. So it's it's like a I think you get what I mean. So give me a minute. So to summarize what I'm talking about, okay, yeah, is only a few easy things, but I say until like I don't know. Okay, anyway. So we talk about P gauge and absolute and atmospheric. We know that P gauge is the gauge. The absolute is the absolute pressure um minus away the atmospheric. Okay, we need to know this. And then if absolute is larger than atmospheric, then it's flowing. Otherwise, it's suction. Okay. So suction, normally you need to remember, just if your overall pressure is lower than atmospheric, you know that there will be a suction in there. So similarly, when you apply this theory into this thing, for piezometer, okay, if it's larger, if the if the water fluid, the pressure in the fluid itself is larger than the atmospheric, there will be nothing, so you can measure. Okay, no, nothing happen. But if you have pressure that is lower, you create suction. Okay, so everything, the atmospheric pressure will try to go in and fill it up, type of thing. So you mess up the whole measurement. So this is why fluid pressure inside the container must be small, so that the height of the column is reasonable. And what the hell is this? Okay, so what does this whole sentence mean is that fluid pressure inside the container must be small, so that the height of the column is reasonable. Reasonable because you want to put a scale over here. Okay, what do I mean? Okay, this is, if you were to use this is a scale, this is a gauge. So the height itself is dependable on the amount of rho and g, right? As you can see the equation itself, the gauge pressure, as you can see, is equals to gamma over h, which is rho g h lah. Okay, so therefore the amount of, so as I say, this is, so if you were to bring this rho g down, if the rho g is big enough, okay, um, the amount of H will actually be smaller. So this is why the amount of fluid have to be kept adequately more, large also lah. So therefore, because mass, the density is proportional to mass, okay, rho equals to m over v. So the amount of mass, if it's larger, okay, if you put a lot of water inside, okay, provided that the height itself is, okay, anyway. So yeah, the amount of mass itself has to be large. Okay, so therefore then you can have this denominator to be large enough to make sure that even if the fluid itself is, the pressure fluid itself is large, if the density itself is much larger than the pressure itself, the H will be smaller. We want the H to be smaller, so that the gauge itself can can gauge for many type of fluids. Okay, because some fluids may have um maybe lighter density. So if lighter density, so this one will be lower, right? So the H will be higher. So therefore maybe if the density itself for the fluid is lower, so maybe the gauge will, the height will start to change into here. So this is another fluid. So the blue color is one fluid, the orange color is another fluid. So it's that meaning. So therefore yeah, so I hope I give you an intonation on this thing, and then it's suitable only for liquid, not for gas. Okay, because gas, maybe I think the density is very low. Okay, so therefore you cannot use this method. So I think I've explained it fairly well. Okay, um and then in the next video I'll just talk about this too. Okay, deriving formula. So as you can see, this portion you only need to derive the understanding. The formula is already given. And then yeah, so see you next video.